Hello everyone, this is Mohammed Jubair, and today I'm going to discuss about my paper DRISHTI, which focuses on uh, line and word segmentation from Bangla handwritten uh, text images. Despite being the sixth most spoken language in the world, very few research has been done on Bangla handwritten recognition, and it's obvious because segmenting Bangla handwritten image is a very challenging task due to its covenant nature and diphthong. We needed instant level segmentation to preserve the order of every instance, in our case, which is lines and words, and to perform the recognition tasks in future. The existing method can be divided into six parts, but we have used a hybrid approach where we have used the Hawk and learning-based techniques. Our overall system architecture can be divided into six parts. Number one, dataset curation. Number two, training yellow models for lines and word prediction. Number three, first line prediction and segmentation. Number four, rotation or skew correction. Number five, second or final line prediction and segmentation. Number six, final word prediction and segmentation. Here we have given it the statistics of our dataset BNHTRD, and in the and on the left we have given the overall procedure of the dataset curation and split, and we are not discussing it because the time is limited, but you can check the precise description on our previous paper, which is cited below. Uh, as as you can see, we have document images on which we have done line annotation, and from the annotated line we have done word annotation, and we use those document images and their line annotation to train the line model, and their word and the line images and their word annotation to train the word model. um, Now we have come to the first line prediction and segmentation part, and on the top left corner we can see the overall procedure, but to give you an overview, we have created an example where we have the first line prediction by line model, where we can see the redundant line, and on the right we can see the filtered first line prediction, where we have filtered the redundant line, and using those bounding box attributes we have segmented the first lines perfectly. And here we have come to the crucial part of our research, which is rotations or skew corrections. It can be divided into two parts. Number one is skew angle estimation through Hawk transform by connecting matra of words. So what is matra? Matra is basically a horizontal top line that connect the characters of a word. It can be divided into two parts. Number one, line skew or LSQ using the standard Hawk transform, and the D skew or the dimension skew using the probability Hawk transform. Just to give an example, we have illustrated two images. On the left we have the negative skew, on the right we have the positive skew, and it has been defined according to the Hawkline's definitions, and where theta is the angle of the detected lines and rho is the distance from the x-axis. As you can see, the red line is the detected lines. If the lines comes down from the top, it is negative skew. If the lines goes up, is we have defined it as positive skew. And the other part of the rotation is the rotation itself through FN transform, which we using the optimal skew angle to make the handwritten line straight by correcting its skew. And now we are gonna see the skew estimation process. On my left, we have given the overall skew estimation process, and we have started with the applying a standard Hawk transform for line skew estimation. First, we have given the line image, first line image, which is basically in RGB form. We have applied grayscale and canny edge detection method as a prerequisite of Hawkline's methods, and then we apply the standard Hawk transform, which detected us various Hawk lines, and among those many Hawk lines we have to select the best ones. Hence we made the average of those lines, and hence we made the average of those lines, and we have got the best handwritten lines. Now you're going to see the published Hawk transform application for DSQ estimation. Now, why DSQ estimation? Because there are a few images on which the standard Hawk transform is not working because the size of or the dimension of the image is very low or below standard. That's why we have to use the probability Hawk transform. Uh, as you can see, the image dimension is very small. We resize the image using the padding and scaling. Then we applied the grayscale and Osu thresholding for binarization, followed by dilation, so that the foreground can be thickened. And then, as usual, we apply the Cannias detection as a prerequisite. Then we apply the published Hawk transform, and as usual, it detected as the Hawk lines. As you can see, it has detected uh, so many Hawk lines as compared to the line skew because it considers all the words within the image. That's why we are calling it dimension skew. Now we have come to the skew correction first. Skew correction process first. We're gonna go through the DSkew. As you can see, we have so many detected hog lines for in on the DSkew process, and that's why we have created a voting process where we basically see where the maximum line has fallen on the quadrants, and which returns a degree average. On the basis of degree average, we calculate the optimal skew, and on the basis of optimal skew, we decide whether to rotate the image clockwise or anti-clockwise. Now we're gonna see the skew correction for line skew. It's very simpler. If we get the negative skew, we rotate the image anti-clockwise. If we get the positive skew, we rotate the image clockwise. We have shown a couple of examples. On my left, we have got a negative skew. As you can see, the angle is positive. That's why we have rotated it anti-clockwise. On my right, we have a segmented line image, first segmented line image, which is skewed, and we have got a negative skew. Hence, we rotated it clockwise. As you can see on the bottom, we have corrected skew of main handle lines. Now to extract main handle lines, we need second or final line predictions. On my left, we have given the overall procedure of the second or final line prediction and segmentation on rotated line images. As you can see, if the line model predict one line, we segment the line as it is. But in all the cases, if the width of the image is less than 50%, then we keep the image as it is. If the line model predict two lines, we segment the image, segment the prediction with maximum width and maximum confidence. If we have three predictions, then we simply take the line on the middle. This is basically the final result of our line segmentation process. Where on the left you can see the first line segmentation before skew correction, and on the right you can see the first line segmentation with skew correction. Where you can see the skew is corrected perfectly, and most importantly, there is no redundant lines which is visible on the first line segmentation, first line segmentation top and bottom. And the final word prediction was straightforward. It was just word predictions on the skew corrected lines or the final segmented lines, and we got this segmented words perfectly. And to evaluate our system, we have taken the evaluation matrices from the ICDAR 2013 line and word segmentation contest, where FM is indicates the F1 measure. Before the comparative analysis, we have compared our results with our previous research group approach, which is BNSTR line segmentation, and our old yellow line model. As you can see, our system outperform those two approaches. But as you can see in the top bottom two column, bottom two row, we have quantitative analysis and qualitative analysis. But why qualitative analysis? Because as you can see in the rotation process, the image went through a drastic change in its dimension. That's why the ground truth and the prediction was not matching perfectly. That's why we have to use the qualitative analysis. As you can see, the qualitative analysis gave us almost the near perfect result, which justifies our system performance. For word segmentation approach, we first did our word prediction on the first segmented lines, as the ground truth was annotated on the skewed lines, and we got matrices which are very poor, On the second row, we have compared the ground truth and the state and the word prediction on the state lines or our final segment lines. And in the quantitative analysis, as you can see, the score becomes even more poorer because the image went through a drastic change, and we have left no other choice but to do qualitative analysis, where we have checked manually with the ground truth and the final word predictions. And as you can see, the FM was almost near perfect. For the comparative analysis, we first chosen the ICDAR 2013 dataset, where we applied our systems, and as you can see, we outperform their top two performer, Gulistan and IMC, in the overall SM score. And we have applied our system on a very popular dataset, Bangla writing dataset, where the word annotation is given perfectly, and hence we have applied our systems on those dataset. And as you can see, the word segmentation results, the FM score is 97%, which indicates that our system can be applied in any form, any type of dataset. And in our last comparative analysis, we have applied our system to W, SUB, and DB text, which is one of the most prominent dataset in the field of handwritten recognition. And as you can see, our system outperform both their lines and word segmentation, which shows the credibility of our system. And now we come to the conclusion of our presentation. If we summarize our presentation, we have extended the BNST dataset by adding 200K plus annotation for Bangla handwritten recognition. The dataset can be used for end-to-end Bangla handwritten document image recognition, word line segmentation, word spotting, image to text conversion, etc. A state-of-the-art system for end-to-end Bangla handwritten document image, line, and word segmentation for STR has been developed by us. Automatic annotation system to annotate lines and words of full Bangla handwritten documents, which is of course in yellow format, and we produce a benchmark score for lines and word segmentation for future researchers. So our ultimate goal is to create an end-to-end Bangla handwritten image recognition system. And that's all for the presentation. Please feel free to ask any question. Thank you.